Everyone, welcome back to another video for the series. I'm Q, and today I brought a problem from USAMO. Yeah, these days I feel like my self-esteem dropped a lot, and that's because the only thing that I'm better at compared to the other ones is inequality, but I was not able to solve this problem, so I was like, I think, yeah, so. And for KMO, we have two algebra problems, and if I get two inequality problems, that would be really lucky. But I'm pretty sure one will be about functional equation, and the other will be about functional equation plus inequality. So yeah. So, and I really need to study more on number theory too, and geometry. But yeah. And also, I just gave up on combinatorics because there's just too much to study from there. And even if I am not able to remember a problem that I solved, then it's like I have a really great chance of not being able to solve that problem. So and also it's usually number 3 or 4 or 7 or 8. So it's just better to not look at those problems for me. And yeah, so please pray for everyone who is preparing for Med Olympiads, and thank you. And yeah, let's get into this problem. My intro was quite long, but it's quite obvious that we need to use Cauchy inequality here, and that's what I did at first. And before doing that, I said without loss of generality, let a sub 1 be the greatest, and like this. Oh. Now, I actually use Cauchy inequality here, but I wasn't able to continue. But what I found really interesting is that the solution switched the position of the first and the last term in the first block. So, meaning like this. Oh. So we just switch the position of these two numbers. Then we do the same for the others. We don't do the same for the other one. We just copy. And by Cauchy inequality, this is obviously greater than or equal to square root of a sub n over a sub 1 plus, how many numbers do we have here? We have n minus 2, because we have total of n numbers and then we are excluding 2 of them. We have n minus 2 plus square roots of this one and this one, so we have a sub 1 over a sub n, and then square. And notice that because this thing is less than or equal to this whole thing, we can write this. This is true. Plus n minus 2 squared. Now notice that this thing, n plus 1 over 2, is positive, and everything here is also positive, meaning n plus 1 over 2 is greater than or equal to this thing. So you have n minus 2 plus a sub 1 plus, and yay, they cancel out. So we have 2 5. Now you know what? Let's actually square this. So we have 25 a sub 1 over a sub n plus a sub n over a sub 1 plus 2. Therefore, we have 17 over 4 is greater than or equal to, yeah. And let's simplify. So we have 17 over 4 a sub 1 a sub n is greater than or equal to, and square plus a sub 1 squared. We have 4a sub 1 squared plus 4a sub n squared minus 17a sub 1 a sub 2 is less than or equal to 0. I hope this is right, and I think we can also factor this thing. So we have 4, 4, 16, and 1. So we have for a sub 1 minus, wait, sorry, 4 a, no, just a sub 1. Why can't I factor? A sub 2 minus 4 a sub 2 is less than or equal to 0. Is this right? This one? Yeah. Oh, it's n. You have 4, 4, yeah. And we know that for a sub 1, wait, sorry. We know that a sub 1 minus 4 a sub n, no. So we know that because we said that a sub 1 is the greatest, this is like obvious. It's just obvious. It's positive. So yeah, that means we can divide this on both sides. So we have a sub 1 is less than or equal to 4 times a sub n. And that proves our prompt. Yes, so for this problem, like I mean, this thing, I think this is like the key takeaway or the kick of this problem. I never saw a problem, or I never solved a problem that involves like switching positions, so maybe that was the reason why I wasn't able to solve it. And now, because I learned this technique, I hope we all can solve this problem solve any problems that are related to these kind of techniques. I really hope that we all can solve a problem in the future where it requires like switching positions, because we solved it today. So thank you so much for watching, and I hope you enjoyed it. Then tomorrow I'll come back with another very fun and interesting problem. And thank you, and see you tomorrow. Bye.